All right, let's continue with trinomial factoring. So the factoring I'm going to do in this video is going to be a lot more difficult because we now have a coefficient in front of the x squared term as well. So there are several different methods for factoring these types of expressions. The one I'm going to show you is a bit more unconventional, but after a bit of practice, it might be a little harder at first, but after a bit of practice, I think it's going to be a lot faster than a lot of other methods that take many more steps. So here is how we factor this. Start by drawing an x like this. And on each end of this x, we're going to place a number. So these are like 4 slots. In the first 2 slots over here on the left of the x, we're going to put factors of 2. So 2 numbers that multiply to 2. This is pretty easy. We can just use 1 and 2. On the right side of the x, we're going to put 2 numbers that multiply to the constant, the number on the right side here. So what are 2 numbers that multiply to 3? That would be 1 and 3. Now here's the tricky part. What we want to do is multiply the numbers being connected by the lines of this x. So first we have 1 times 3 is 3. And then on the other line in the x, we have 2 times 1, which is 2. And now we add these 2 results. 3 plus 2 will equal 5. And what we want to do is make sure that this is the same as the number in front of the x. And so we have 5 on both, so that means this is the correct factorization. Now, but what does this little x mean with all of these numbers? Well, it's actually quite simple. These are the coefficients of the factored result. So we now look at the top row, 1 and 1. So this is 1x plus 1. That's going to be x plus 1 times 2x plus 3. And we are done. That is the factored result of this expression. And we can see that that's true if we were to undo this, simplify it back out. X times 2x is 2x squared, plus 3x plus 2x will be plus 5x, and plus 1 times 3 is 3. Okay, that might have been a little confusing, but don't worry, we have several more examples here. So again, first thing you do is draw the x. On the left side of the x, the factors that multiply to the number, the coefficient of the x squared term. So factors of 3 would be 1 and 3. Then on the right side, it's factors that multiply to the number out here. On the right, factors of 5 would be 1 and 5. Now we multiply across the lines of the x. 1 times 5 is 5. 3 times 1 is 3. And then we add those 2 results. 5 plus 3 is 8. Since that is the same number as the coefficient of the x in the middle, we know that this will give us the correct factorization. So we have 1 and 1 here. That is 1x plus 1 times 3x plus 5. And we're done. Okay, now we're going to make things a little more challenging here as the numbers get bigger. Okay, so draw the x. Factors of 7 are 1 and 7. Now here's what gets a little more tricky. There are two possible factors of 4, either 1 and 4 multiply to 4, or 2 times 2 multiplies to 4. So what we have to do is try them both and see which one is correct. So first we'll try it with 1 and 4. So in order to test if this is the right one, we multiply across the x's. 1 times 4 is 4. 7 times 1 is 7. We add them, we get 11. That is not 16, so this is incorrect. So now we try it again. Factors of 7 have to be 1 and 7, but we'll use different factors of 4. We will do 2 and 2 this time. Now when we multiply across, 1 times 2 is 2. 7 times 2 is 14. We add those and we get 16. So since we got 16 and we have 16x here, this one is the correct factorization. So we're going to use that to produce the factored result. The top row will be x plus 2, and the bottom row will be 7x plus 2. All right, let's do another one like that. Factors of 5 are 1 and 5. Factors of 4 again can be 1 and 4 or 2 and 2. So we'll first try 1 and 4. This will be 4 plus 5. That's 9. So that is not correct. Let's try it again with 2 and 2. 1 times 2 is 2. 5 times 2 is 10. So this will add to 12, which again is incorrect. Turns out there is a third possibility. If we flip the 4 and the 1 here, instead of having 1 and 4, we're going to do 4 on top, 1 on the bottom. Again, 4 times 1 are the factors of 4, so they can be in either order, and this will produce different results because of the way we're multiplying diagonally across the x. 1 times 1 is 1. 5 times 4 is 20. This will be 21. And now we have the 21 in front of the x here. So this one is the correct factorization. So this will be x plus 4 times 5x plus 1. Okay, so now in order to make this process go faster, we're going to see if we can start doing some of that guess and check in our head. So we know the factors of 3 have to be 1 and 3. But now, for factors of 6, we have two different possibilities again. It could either be 1 and 6 or 2 and 3, and both of those can be flipped. We could then have 6 and 1 or 3 and 2. Since they're different numbers, they can both be flipped. So let's see if we can figure out which is the right one without trying them all. Look at the number in front of the x. It's 9. Considering that that's pretty low, especially to something like in the last problems. In these last two, we've had 16 and 21, so we've had to end up with big numbers, big coefficients of x. But 9's pretty low. So what that means is we're probably going to be trying to get the lowest result possible. So how can we arrange the factors of 6 in order to get the lowest number when we do the multiplying across of the x? We want both numbers when we multiply to be as low as possible. Well, think about it. We have a 1 here and a 3 here. So since we're multiplying by 3 here, whatever number we put at the end of this line in the x is going to be multiplied by 3 and therefore greatly increase the overall result. So let's put the smallest number possible across from this line on the 3. The smallest factor of 6 is going to be 1. And if we use 1, then the other one, 1 times what equals 6? 1 times 6 equals 6. So now we can see when we multiply across, it'll be 6 plus 3, and that's 9. There we go, we're done. This is the correct factorization. X plus 1 times 3x plus 6. Without having to try all of them, we were able to figure out which might be the right one using a little bit of reasoning. Okay, this one, factors of 2 are 1 and 2. Now for 8, again we have two possible combinations, 1 and 8 or 2 and 4, and since those can both be flipped, there are really 4 possibilities. But now look, the number in front of x is 17. Which is a pretty large number. So this time we can guess that we're going to be trying to go for a larger number. So what that means is we probably want to have a larger number across from this 2 here, since it will be multiplied by twice as much as if we were to put across from the 1. So what's the largest number we can put across from the 2? Well, it would be a factor of 8, which is 8. And then the other one can be 1. And here we'll see 1 times 1 is 1, plus 2 times 8 is 16, and that will indeed give us 17. So the factored result is going to be x plus 8 times 2x plus 1. Okay, factors of 7 are 1 and 7. Now, factors of 12. Oh boy, there's a lot this time. We have 1 and 12, 2 and 6, 3 and 4, and then those can all be reversed for a total of 6 combinations. So let's eliminate as many as possible right from the start. We know that we are probably going to want to have a smaller number, the smaller factor, across from the 7. With 1 and 7, that's a dramatic difference. Whatever number is being multiplied by the 7 will grow much, much larger than by the 1. So 25 is pretty big, but considering there's a 7 here, it's not really that big. So we can assume that we're going to have the smaller number across from the 7. So now the question is, which smaller number is it? It's either going to be 1 and 12, 2 and 6, or 3 and 4. So let's start with 1 and 12. If we multiply 1 times 12, that's 12. 7 times 1 will be 7. So this will be 19. Not quite high enough. We'll try again with 2 and 6. We'll get 14 plus 6. That'll be 20. Still not high enough. So now we'll try it with 3 and 4. This will be 4 plus 21 is 25. There we go. Now we got the 25x. So this is the correct factorization, and this will be x plus 3 times 7x plus 4. All right, we are going to stop there, but there is still a lot more to come with advanced trinomial factoring. I think we're going to make this a 3-part series of videos because these do get a lot harder even from here. So if you're not comfortable with these level of problems, make sure you do some practice before you move on to harder ones.